So dear participants, let us get into one very interesting operation of this internal relays. This is termed as one-shot operation. It is basically the ability to program an internal relay in such a manner that its contacts are activated for one cycle only. One cycle means we are talking about one complete scan through the entire ladder program by the PLC. Now when such an operation takes place, then the internal relay, they provide you a fixed duration pulse at its contacts, and this function is known as one-shot operation. Nowadays most of the PLCs, they have inbuilt one-shot operation. However, even if it is not there in the PLC, you can use internal relays very efficiently for any of such operation. Let us see. This is the example of a ladder diagram where one shot operation has been carried out. You can see this is the trigger input and this is the trigger output, and you can find that although the trigger input is continuously on, that means this discrete signal is continuously at its high condition, the output that you are getting a fixed pulse, and this duration of this pulse in one cycle of the PLC program. On the right side you can find that such facility is inbuilt in an Allen Bradley PLC as ONS block, and this is also available in a Mitsubishi PLC as PLS block. Now see here, we will try to find out the operation of this one-shot facility. And I'm not talking about the facility actually, we are creating an one-shot operation using an internal relay. Now you see here in this particular ladder diagram, the trigger input is the external input and the trigger output is the external output. This cycle control is the internal relay. Whenever the trigger input is triggered, that means we activate this, then it is activating two different output coils. One is the trigger output and other is the cycle control output. Now you see, this is not a physical output, this is an internal relay. So let us rectify our statement. Whenever the trigger input is enabled, then one external output and one internal relay, both of them get activated. Now you see here what happens. Whenever we put the trigger input on, then the trigger output, that is activated, and when the trigger output is activated, then the question is definitely very justified that what is the role of this cycle control. You can see initially this cycle control internal relay, it is in off condition. When this is in off condition or deactivated condition, then there are again two contacts of this relay, one is NO and other is NC. This NC contact is present here. So since this is in deactivated condition, whenever the trigger input is activated, then this trigger output is activated. So you can see here as well, as soon as the trigger input is activated, the trigger output is also activated. Now you see that scanning of the program starts from this point, it will go to this point, then it will come at this point. At this point, what you will find, the trigger input is activated. So now the cycle control will get activated. Once the cycle control is activated and the program is over, then the PLC will start again scanning back from point rung 1. So here when the signal goes, what will happen? Now you see here, this cycle control is now activated. Since it is activated, at this point of time, the NC, it will become NO. Since this has been activated, the normally closed contact will now become open. As soon as it become open, the trigger output will get deactivated. Now, the trigger output will be deactivated But on the other hand, you can see that the trigger input is still activated. It can remain activated or it can be deactivated, no problem. You got my point? Irrespective of the point that whether the trigger input is present or not, since this cycle control has been deactivated, the cycle control has been activated, this NC contact now has become NO, and accordingly you are having no output here. So your signal will be at low again. Now try to understand that if we again want to have a trigger output, what we need to do? We need to put the trigger input off. We need to put the trigger input off. When the trigger input is off, then this cycle control will be deactivated. When this cycle control is deactivated, then this terminal again becomes NC. Now since this terminal has become NC, now you are again allowed to activate the trigger input if you want a trigger output again. So this is the entire thing. You can see. The beautiful thing is that you see that rung 2 occurs after rung 1, and therefore the effect of cycle control is not felt until the next cycle of the PLC program. यहाँ पे क्या हुआ देखो, सबसे पहले आपने इसको एक्टिवेट कर दिया, फाइन, कोई प्रॉब्लम नहीं. इसके बाद साइकिल कंट्रोल भी एक्टिवेटेड हुआ. अभी आप पूछोगे सर इमीडिएटली साइकिल कंट्रोल ऑफ क्यों नहीं हुआ? क्यों नहीं हुआ उसका कारण है. सबसे पहले क्या हुआ, आप यहाँ से ट्रिगर आउटपुट को एक्टिवेट कर दिए. एक्टिवेट कर देने के बाद पीएलसी को टाइम लगा, वो ट्रिगर इनपुट पे यहाँ पे गया. यहाँ पे जाने के बाद देखा ट्रिगर इनपुट ऑन है तो साइकिल कंट्रोल को ऑन किया. इमीडिएटली ऑफ नहीं होगा, ये पीएलसी को वापस जाना पड़ेगा. वापस जाने के बाद व्हेन इट विल कम टू दिस रंग, इट विल फाइंड अरे ये तो ऑन हो गया है तो इसको ऑफ कर देना पड़ेगा, आपकी सर्किट ऑफ हो जाएगी. सो दिस मच टाइम डिले विल गिव यू द ट्रिगर आउटपुट ऑफ ए गिवन ड्यूरेशन. नाउ सी, इफ इस लाइन के बाद और 10 लाइन है, समझो 10 रंग की प्रोग्राम है, तो पीएलसी क्या करेगा, यहाँ पे शुरू होगा, यहाँ पे जाएगा, हर एक रंग कंप्लीट करेगा. कंप्लीट करके जब वापस आएगा तब जाके इसको ऑफ कराएगा. सो नाउ यू सी दैट वन शॉट ऑपरेशन आप ले सकते हो. यहाँ पे काफ़ी सारे एनओपी नो ऑपरेशन डाल के आप वन शॉट ऑपरेशन में इस ट्रिगर आउटपुट की जो ड्यूरेशन है उसको बढ़ा भी सकते हो. सो इट इज़ लाइक दैट. नाउ यू सी हियर, यहाँ से एक बहुत इंपॉर्टेंट कंसेप्ट है जिसकी शुरुआत होती है, विच इज़ व्हाट इज कॉल्ड एज पॉजिटिव एंड नेगेटिव ट्रांजिशन. सो दिस पॉजिटिव एंड नेगेटिव ट्रांजिशन, इन ऑर्डर टू मेक दिस understand, I will be using AB notation, that is Allen Bradley notation. Suppose we are using an Allen Bradley PLC. The output internal relay, say B3001, this is the output internal relay, is activated when a trigger input, say I00101, that means module 1, rack 1, terminal 1. This particular thing, this trigger input, the contacts are closed. Contacts are closed means this internal relay will be activated. Now under normal circumstances, B3001 would remain on as long as the input contacts are closed. Very simple, because this input contact is directly connected to the B3001. So whenever this is on, B3001 will remain on. However, now comes the particular thing. If B3001 has been programmed for pulse operation, just now as we have seen, it will remain on for a fixed period of time, and this fixed period of time is one program cycle. Then it goes off. Regardless of I00101, which is where input, it is remaining on or not. अभी इस प्रकार को समझने की कोशिश कीजिए. When it goes off, this B3001 goes off after a fixed period of time, and this fixed period of time is given by one program cycle. इसके बाद आपकी इनपुट ऑन रहे कि ऑफ रहे, डजेंट मैटर, B3001 ऑफ हो गया. अभी आप देखिए क्या बताया जाने की कोशिश किया जा रहा है. द प्रीसीडिंग कंडीशन रिप्रेजेंट्स pulse operation when input goes from off to on. That means यहाँ पे क्या हुआ, आपको एक पल्स मिली. कब मिला? जब आपकी इनपुट ऑफ से ऑन हुआ. That means you get the pulse. You can see here, you get this pulse whenever your input is changing from off state to on state. It is changing from off state to on state. Then only actually you are getting the pulse. Okay. If the trigger input is made normally closed then normally open. इसका मतलब क्या हुआ? यहाँ पे आप एक normally closed switch इस्तेमाल कीजिए. अगर normally closed रहा तो ये high रहेगा. जब उसको आप ऑफ करेंगे दैट मीन्स यहाँ पे हाई रहने के बाद सिंपल इसकी उल्टी होगी. Whenever the trigger input is made normally closed rather than normally open, the pulse occurs when the input goes from on to off. Earlier it was on, then it should be off, then the situation will happen. In other words, this is what is called as negative going effect. So in the first case, you are giving a positive going edge of the pulse in order to get a fixed pulse at the internal memory. जब ही इनपुट ऑफ से ऑन होता है दैट मीन्स पॉजिटिव एज ट्रिगर होता है तब आपको यहाँ पे पल्स मिलता है. और इसमें क्या हो रहा है? पॉजिटिव से नेगेटिव हुआ, ऑफ ऑन कंडीशन से ऑफ हुआ. When the trigger input is made normally closed, that means it is in on condition. On condition से ऑफ हो गया. ऐसे कंडीशन में आपको क्या मिलेगा? जब वो ऑन से ऑफ होगा तब आपको जाके वो पल्स ड्यूरेशन की पल्स मिल जाएगी. सो देयरफॉर दिस इज व्हाट इज कॉल्ड एज पॉजिटिव एंड नेगेटिव ट्रांजिशन कॉइल. Right, so you can see that this particular coil, it can sense a positive transition, and this particular coil, when it is given as N in Allen-Bradley notation, it is called as negative transition sensing coil. In one case it senses a positive transition, and in other case it senses a negative condition. Now condition means transition. I am talking of transition. So the most important thing is here there is a facility that is inbuilt in many of the Allen-Bradley PLCs is a positive transition sensing coil and a negative transition sensing coil. In the first case, when your input makes a transition from off to on, the sensing coil will be activated, and in the other case, when there is a transition of the input signal from off to on, then there will be a pulse at the this negative transition sensing coil. You can see here, this is the ladder rung with a positive transition sensing coil. This is the input, this is the positive transition sensing coil. Now you can see when the input is off, the output is off. When the input is on, then the pulse transition sensing coil will be high. However, when it remains on, this will remain high for predetermined amount of time, and then it will be off. So here the transition takes place actually off to on. So whenever the transition is there, then only you get the pulse. So negative edge trigger and positive edge trigger, these are the two important aspects in electronics, and this is how you achieve a positive edge triggering and negative edge triggering in case of a PLC. So that's all about this positive and negative edge triggered sensing coil. Now you see that there is another concept in the internal relays, and that is battery backup. Now you see, many times it happens that you need to ensure that even if there is a power failure, your memory conditions should be retained. So under such circumstances, there are several internal relays, they have their own battery backup, so that they can be used in circuits to ensure a safe shutdown of a plant in the event of a power failure. Now that doesn't mean that your entire PLC will be battery backed up. Only some internal relays are battery backed up in order to ensure that in case of any insurgency, you can safely shut down the system. That is important, because it may so happen that your PLC is in some sequence of control of actions, and if it is left over there, then when the power will resume, it will start from a different point in the sequence and some calamity may take place. Therefore, there is necessity that internal relays, some of the internal relays, they have battery backup. Now, such battery backed relays retain their state of activation even when the power is off. Therefore, such relays are said to be retentive relays. And the terminology that is used is retentive memory coil. Retentive memory coil. Retentive memory coil are shown in this fashion. That is a simple coil with an M inside. That means it is having a retentive memory. So that's all about internal relay. In the last phase of lecture of unit 1, we will be discussing on some of the program examples, and we will see how from control description of a process we can design a ladder diagram. Thank you.